At the university this semester, there are 105 students in the biology chemistry program. The Venn diagram shows 3 of the courses the students may register for. The number of students taking all 3 courses is denoted by X. 50 take the chemistry course, that's C. All chemistry students are also mathematics students, that's M. 64 take biology, that's B. 16 take mathematics only. 9 take mathematics and biology only. And 5 take none of the 3. And so what they want us to do is they want us to copy and complete the Venn diagram in terms of X where applicable. And so notice that we have X in the middle. It says that the number of students taking all 3 courses is denoted by X. So X must be in the middle. Next, what do we have? Well, they tell us that 5 take none of the 3. So that's why 5 is on the outside of the circles because 5 take none of the 3. Next, they tell us that, okay, 9 take mathematics and biology only. And so 9 is going to be here. And then it says 16 take mathematics only. So 16 is going to be here for mathematics only. Next, they tell us that 50 take chemistry course. So this circle right here is for chemistry. And that is 50 because the number of elements inside this set has to be 50 because 50 take chemistry course. So if this total thing is 50, and we know that this part is X, then this part must be 50 minus X. Now they said that 64 take biology, B. And so that means that this whole circle right here, right, is for biology. This whole thing is for biology. And 64, right, and that means that the number of elements inside this particular set that I have here, this set B, the biology, the number of elements inside of it is going to be 64 rather, because 64 take biology. So this whole thing is going to be 64. Altogether, it's going to be 64. But if we know that this part is X and we know that this part is 9, then that means that this part right here, biology only, is going to be 64 minus X plus 9 because we have X here and 9 here, okay? And so here we have completed this Venn diagram in terms of X where applicable. And so let's write an equation in terms of X and then solve it. Now bear in mind that there are 105 students in the biology chemistry program. And so we're going to use that in writing an equation. So we have 64 minus X plus 9, which we have here, plus 9 plus X plus 50 minus X plus 16 plus 5 must be equal to 105 because there are 105 students in the biology chemistry program. And so this is the equation that we have, and we're going to simplify this equation and we're going to solve this equation for X. And what are we going to do? Well, the first thing that we do is we distribute. So we take negative 1 and we multiply it by X, and we have negative 1 multiplied by positive 9. And so when we do that, what do we have? Well, we have negative 1 multiplied by X is going to be negative X. And negative 1 multiplied by 9 is negative 9. And so we have 64 minus X minus 9 plus 9 plus X plus 50 minus X plus 16 plus 5 is equal to 105. Next, we group our like terms. So we put all of the numbers together and we put all of the X's together. Next, we add up all of the numbers, or we operate on all of the numbers, or I should say we perform the operations between the numbers. So 64 minus 9 plus 9 plus 50 plus 16 plus 5. And so all of that gives us 135. And we still have the X's right here. Next, we say, okay, well, negative X plus X, well, those two cancel with each other because if you have negative X plus X, we could cancel them because that gives us a 0. And so we are just left with negative X. So we have 135 minus X is equal to 104. I'm sorry, we have 135 minus X is equal to 105. We take the 135 and we send it over the equal sign. So again, we had 135 minus x is equal to 105. We take the 135 and we send it over the equal sign. And so we have negative x is equal to 105 minus 135. And we subtract these two terms. And when we subtract them, we get negative 30. So negative x is equal to negative 30. We divide both sides of this equation by negative 1. And this cancel with that. So we get that x is equal to negative 30 divided by negative 1. So that means that x is equal to 30. So in this case, x is equal to 30. And so we wrote an equation and we solve it for x. Now it says here, calculate the value of the number of elements in M intersect B. M intersect B. So what is M intersect B? What is that going to be? All right, so M intersect B. So here, M intersect B is, so this right here is M, this whole thing is M, this whole circle is M, and then this is B. So M intersect B is going to be right here. All right, this intersection. All right, that's the intersection of M and B. So what is M and B? That's going to be X plus 9, right? The intersection of M plus B, the number of elements in the intersection of M union B. I'm sorry. The number of elements in the intersection of M and B is going to be X plus 9 because we have X here or we have a 9 here. What is X? Well, X is 30, so it's going to be 30 plus 9, and 30 plus 9 is 39. And so the number of elements in M intersect B is going to be X plus 9, and that's going to be 30 plus 9, which is 39. Next, we need to figure out what is the number of elements in C complement. And so when we have C complement, what does that mean? Well, C complement, what that basically means is that what we're going to do is we're going to take all of the elements in the universal set, all of the elements in the universal set. We can include all of the elements in the universal set, except for, let me erase this. So erase this time. So we take all of the elements in the universal set, right? Except for the elements in C. So we do not include the elements in C. We include all of the elements in the universal set. All of them are fine, but we do not include any of the elements that are in C. So C is the set C, and the elements in set C are off limit. We cannot include them. All right. So, but we can include all of the elements in the universal set, but we cannot include any of the elements that are in C. All right. And so, and C is for chemistry. All right. And so what does that mean? That means that we cannot include any of the elements that are inside here. Okay, so what all do we have inside of the complement, right? So inside the complement we have 64 minus x minus, we have 64 minus x plus 9. So we have 64 minus x plus 9. We have 9, all right? We have 16, and we have 5. We cannot include x, and we cannot include 50 minus x. And so let's operate on that. So we have 64 minus x plus 9. So that's what we have here, 64 minus x plus 9. We have 9, which is here, right? We have a 9, which is here. We have 5, which is here. And we have 16, which is here. Now, what is x? Well, x is 30, so we substitute 30 in here. So we add up all of these numbers, 16, 5, 9, and 64, and that gives us 94. But we have to subtract it with 39 because x is 30 and 30 plus 9 is 39. So it's going to be 94 minus 30 plus 9, and 30 plus 9 is 39. And so 94 minus 39 is definitely going to be 55. And so that means that the number of elements in that means that the number of elements in C complement is definitely equal to 55. Next, we want to figure out, let me erase all link. So erase all of this. So next we need to determine calculate the number of students So they want us to calculate the number of students who take one of the courses only, who take one of the courses only. And so in order for us to get that, that's going to be, well, that's highlighted, right? On the number of students who take one of the courses only. All right, so one of the courses only would be biology only, and biology only would be 64 minus x plus 9, and then you have math only, right? And math only is 16. Now you cannot include chemistry because if the student takes chemistry, they have to take math, so that wouldn't be only one course, all right? So all of the students who take chemistry, they take math, so it wouldn't be one course. So we only have biology only and mathematics only. And so let's simplify this expression. So we have, we substitute x is equal to, we replace x with 30. And so this is gonna be 30 plus 9. And 30 plus 9 is 39. So we have 64 minus 39 plus 16, and that gives us 41. So that means that the number of students who take one of the courses only is 41. Okay, next, what they want us to do, calculate the number of students who take two of the courses only, two of the courses only. So two of the courses only would be 9 plus 50 minus x. Now, why is that? Well, we have 9 because 9 represents biology and mathematics, right? Only, right? So 9 people take biology and mathematics only. And then 50 minus x, well, that represents those who take chemistry and math only, all right? And so we have two of these courses, biology and math only is 9, and chemistry and math is going to be, 50 minus x, all right, chemistry and math, because if you're in chemistry, you're also in math here, but this one is chemistry only and math only. So they take both chemistry and math. Okay, so let's operate on that. So we say, so we substitute, so we say x is 30. So we have 9 plus 50 minus 30, and that gives us 29. And that's the answer to this particular question. Next, we want to figure out those who take at least two of the courses, all right? So at least two of the courses would be 9 plus 50 minus x plus x. Now, why is that the case? At least two means, what does at least two means? At least two means two courses or more, all right? So two courses or more. So let's start with two courses. People who take two courses. So we know 9 people take biology and math. We know that 50 minus x people take chemistry and math. So that's two courses, but it says or more. And then we know that x people take all three. So it's gonna be, we're gonna add x here. And so what do we have? Well, we have 9 plus 50. And the reason why we say have 9 plus 50, because if you notice carefully, we have negative x plus x. So we have negative x plus x. So those two cancel out each other. And so we just left with 9 plus 50. And 9 plus 50 is definitely 59. And so the number of students who take at least two of these courses is definitely going to be 59. And that's the answer to this particular question.